our second interpreter first assume we're going to give each page a score. This is score for the relative importance, or say the rank. The highest value, the better off it is. Let's normalize this number between 0 to 1. If it's 0, means it's the least important. If it's 1, means it's the most important, like Google itself. And how about not a count, but the relative importance is add other backlinks. For example, if you look at the diagram again, instead of counting how many backlinks, I look at the first page. This is the score. It have two contributors. One is the fourth page. You can see that's the fourth page. And another one is the third page. And then the score of the first page is adding the third and the fourth page score. And if I look at the second one, only got one link, you can add to the score of the first page. And similarly, the third page, you add all the three links, x1, x2, and x4. And then the fourth page, simpler, got the first page and the second page. Does this work? Well, at least we include the relative importance of the page into the scoring system. But are there any problems? Let's look what's wrong with this. Well, if you do this way, I only count this weight of those contributions. And if in such a way I can significantly boost other people's website, then again I can make a company to just write links, give each link some money, and then I boost other people simultaneously. Also could boost myself, because I can earn the money and also get a reputation. Everybody wants me to link to this. Or think another way. If, say, Yahoo, write millions of links to backlink to everybody, and then that reference does not contribute that much. Just like in a democratic society, each person have your one single vote. You don't vote millions of people, and then millions of times, then you get too much influence. So the shortcoming of this idea is you have to consider a fraction of the contribution if you get multiple links. What I'm saying is, let's back to the example. You look at the third page. The third page only voted for or linked to the first page. Then the total weight reference of the third page given 100% to the first page. On the other hand, you look at the second page, it voted or linked to the third page and the fourth page. Then a proper way, probably think about the contribution of the second page, give half to the third page and the half to the fourth page. That's a little more fair system. So in the end, every page, regardless of how many links you send out, you totally only got 1 vote. That is more democratic. So once you understand this idea, we just need to do a little adjustment to the second attempt. Let me call this as the third modifications. And if page ij contains nj links, that means this page j send out nj links to the other pages, or let me just call it voted nj pages. And then the contribution to boost to the k page, let's say send 1 to the page k. And the score of the page k, we call it xk. And then in that case, xk only overturned this much boost of the score. So xj is the score of the voter, and xk is the benefactor from the voter. So now if this xj voted to nj people, you simply need to divide the contribution by nj. So how much really this page xk gain? It gains this much, xj divided by nj. It's not that complicated, because you may don't like this abstract j and the k. You just go back. Look, we said, for example, the x3 have only 1 vote, all given to x1, and then the x1 need to get the whole x3. But the x1 only get a fraction of the x4. How much? x4 give out 2 links, half of x4, because that's what we mean. And also look at the, so x1 has 2 backlinks, got 100% for this. That's why you add the whole x3. Get the half of x4, because x4 give out 2 links, 1 and 2. So that's what x1 get. Now x2, how much we got? x2 only got 1 backlink from x1. And then you got the x1, and the x3 got 3 backlinks, 1, 2, 3. Got the third from x1. Why? Because x1 gives 3 out, 1, 2, and 3. That's why it's 1/3. And how much from the x4 is 1/2, because x4 got 2 pages. How much from x2? x2 give 2, is 1/2 of x2. Well, you got all those equations. And how about x4? x4 got the 1, 2 backlink. You get the 1/2 of x2. Here's 1/2 because it give out 2. And 1/3 of x1. Well, you got a bunch of algebraic equations. So now I write what I found into the algebraic equation. Check one more time to make sure we understand. Every page has a score. The score is a vector. You can call it x1, x2, x3, x4. If you have 400 pages, you got a vector of a 400 element. So x1 is the first element represented the score of this page. And the L1 is the link, the back link. The L1 is the third page and the fourth page. That's why x1, you got 100% of x3 because this x3 only got this way. There's no other outer link. And x2, I got a half just to give equal to this 2. Then I got a half of the x4. That's what we have here. And the x2 only got one inward link. Then got the third of x1. Why 1/3? See, x1 goes 1, 2, 3. 3 outer link. That 3 is where the 3 come from. And then we do the same thing. The x3 got 3 links, but only got 1/3 of x1 and half of x2 and half of the x4. Now here's what you need to pay attention. Previously, if we simply count the backlinks, the page 3 is the most important. But look, this page 3 is really selfless or sacrificing itself to the x1 because he gave 100% to x1. And from that equation, you can clearly see it's bigger than x3 because the whole x3 given to x1. But as a return, the x1 only give 1/3 to x3. And the x3 got some other contribution. The x4 got the 2 in here and here. Third of x1, half of x2. All right, now the last step for today, for this time, is write into a matrix form of an equation. So we write as ax equal x. Well, check one more time before we stop. This A, what do we call? Coefficient matrix, right? And then the equation is ax equal x itself. You see, that's the x, that's the ax. And what is special for A? If you check each column, you add equal 1. This is the first page, give 2 outer link. Second page, give only 1 outer link, 1 in link, a back link. Third page, fourth page. So each column is really the links sent out. So you add 1/2 times 1/2, add 1/2 is 1, that's 1. 3 1/3 is 1, 1/2, 1/2 is 1. And this kind of matrix, we have a name called the stochastic matrix. I'm going to give a formal definition later. But you know why add to 1? Because it's a fair voting system. You only vote 1 altogether. It's 100%.